Math 2, Unit 10, Part 2, Module 4, Topic 1, Test Review. In the first section, we're going to be factoring each expression completely. Every time you're factoring, if you see a greatest common factor, you always want to try to factor that out first. So in Part A, I do not see a greatest common factor other than the number 1. The next thing I'm looking at is how many terms I have. So I see 3 terms, so I know it's a trinomial. When I look at the front of the trinomial, there's an invisible 1 in front of the x squared. So this is a basic trinomial as opposed to advanced factoring that we'll practice later on. So when you're doing a basic trinomial factoring problem, you want to find 2 numbers that multiply to the c value in the back, and then those same 2 numbers need to add up to the b value in the middle. So 5 divided by 1 is 5. 1 plus 5 is 6. So this is just going to factor into x plus 1 and x plus 5. Because again, 1 times 5 is 5, and then 1 plus 5 is 6. Remember, if we were to FOIL this back out or multiply this back out, we would get what we started with, because factoring and multiplying are inverse operations of each other. They undo each other. If you're wondering where the x and the x came from, that was us just splitting the x squared into x times x. On letter B, is there a greatest common factor other than 1? No. How many terms are there? 2. And it is subtraction. So anytime it's subtraction and it's 2 terms, you want to double check and see if it's a difference of 2 perfect squares. You'll know it's a difference of 2 perfect squares if both of your terms are perfect squares. So on this particular problem, yes, x squared is a perfect square. So you do the square root of the first term, so square root of x squared is x, and that goes in the first slot in the 2 sets of parentheses. And then you do the square root of the second term, so square root of 144 is 12. That goes in the second slot of the 2 sets of parentheses. Make one positive, make one negative, and then that's it. That's your answer. For letter C, is there a greatest common factor other than 1? Yes. All of those coefficients are divisible by 2. Since the first term is negative, we want to take out a greatest common factor of negative 2. That'll make factoring the leftovers in the parentheses easier. So that's why we've trained ourselves to divide out a negative GCF if the first term is negative. So now, looking at the leftovers in the parentheses, we want to see if we can factor those as well. Sometimes we can, sometimes we can't. So I'm seeing 3 terms in the parentheses. I'm seeing an invisible 1 in front of the x squared, which means it's a basic trinomial as opposed to advanced factoring. So this will be like letter A. So we're looking for 2 numbers that multiply to the number in the back, and then those same 2 numbers need to add up to the b value in the middle in front of the x. So 21 divided by 1 is 21. If I'm trying to multiply to a negative number, one of my numbers has to be negative. If I'm trying to add up to a positive 4, I need my bigger number to be positive and my smaller number to be negative. So I'm going to put a negative sign on the 1. Negative 1 plus 21 is 20, so that does not work. I'll try the next number. 21 divided by 2 is a decimal, so I won't even bother writing that down. Let me try 3. 21 divided by 3 is 7. Bigger number has to be positive because I'm trying to add up to a positive 4. And sure enough, that works. So make sure you drag down that negative 2 in the front. And then the leftovers are the basic trinomial that get factored into x minus 3 and x plus 7. And there you go. That's your answer. Part D, greatest common factor. So both terms are divisible by 7, and the first term's negative, so I'm going to do negative 7. And then both terms have at least an x squared. So negative 7x squared for my GCF. So I take my negative 7x squared out in the front, and then when I'm dividing, in that first term, negative 7 divided by itself cancels out. X to the third divided by x squared. When you're dividing like bases, you subtract the exponents. So 3 minus 2 is 1. But that little 1 that I just wrote in there, I never actually leave that in my final answer, so I'm actually going to get rid of that. Second term, 21 divided by negative 7 is negative 3, and then x squared divided by itself cancels out. Looking at the leftovers in the parentheses, x minus 3, you have two terms, it's subtraction, but neither of those terms are perfect squares, and there is no GCF. There's nothing else we can really do with this because you're left with a linear factor in your parentheses. So that's it. That's as far as you can go. Looking at letter E, is there a GCF? Looks like everything's divisible by 2. And then what about the variables? I feel like they all have an x. Let's see. Yep. So everything is divisible by 2x. So if there's a greatest common factor, always divide that out in front first. And then as far as the leftovers in parentheses go, sometimes you can factor them and sometimes you cannot. In this particular problem, our leftovers are a basic trinomial, just like in letter A. And I know that because there's an invisible 1 in front of the x squared. So I want to find two numbers that multiply to the number in the back, and then those same two numbers need to add to the number in the middle. So multiply to 24, add to 10. Just to speed up the time a little bit here, I'm just going to jump to the answer. So 4 times 6 is 24, 4 plus 6 is 10. So drag down your 2x in the front, and then you do x plus 4 and x plus 6. If you couldn't think of the 4 and the 6 right off the top of your head, that's when you would try, 1 and 24, 2 and 12, 3 and 8. You would just try all of those, but I skipped writing them down to save time. And then that last one, part F, is there a GCF other than 1? No. How many terms do we see? 3. Is the A value an invisible 1? No, it's not. It's a 2. So this is going to be advanced factoring. So with advanced factoring, you want to find two numbers that multiply to whatever A times C is, and then those same two numbers need to add up to what B is. So A is 2 and C is 3. So 2 times 3 is 6. B is 7. So I want to multiply to 6 and add to 7. And lucky for us, the very first one we try works. 1 times 6 is 6, and 1 plus 6 is 7. Now, since this is advanced factoring, we cannot just jump to the answer like we did in part A. We have to split our middle x term. So what's going to happen is we'll drag down the 2x squared. We're going to split 7x into 1x and 6x, and then we'll drag down the plus 3 in the back. So we just made our trinomial into a 4-termed polynomial. Now we're going to do factor by grouping. So you group the first two terms in parentheses, group the second two terms in parentheses. And then looking at the first set of parentheses, I have a greatest common factor of x. So I'm going to divide an x out in front, and then my leftovers are x plus 1. Second set of parentheses in the back, I can divide a GCF of 3 out in the front. Leftovers from my parentheses in the back. I feel like I made a mistake. Yes. If you look back at that first set of parentheses, when I was dividing my leftovers, I had put just an x. I'm missing a 2, because 2x squared divided by x isn't just x, it's 2x. The reason I recognize my mistake is because when I went to the second set of parentheses, when I was going to do 6x divided by 3, I was going to get 2x, and I noticed that that didn't match my leftovers in my first set of parentheses. So I knew something was wrong because your parentheses have to match. Now that those blue 2x plus 1s match, you divide the 2x plus 1 out in the front as a greatest common factor. Let me make that a little less messy there. So 2x plus 1 out in the front in parentheses. And then you have the red x plus 3 as your leftovers in the back. And then that is your answer. Number 2, solve each by factoring, which sometimes it might say something like find the solutions to the equation or to the polynomial below. So on part A, everything's already on one side equal to 0. If you ever see a problem like this where you have terms on both sides of the equal sign, you want to get everything on one side and set it equal to 0 before you dive into trying to factor. So on letter A, I do not see a GCF other than 1. It's a trinomial, and there's an invisible 1 in the front, so it's a basic trinomial. So I want to find two numbers that multiply to 8 and add to -9. So if I try 1, 8 divided by 1 is 8, and then I am supposed to be adding to -9, and both of my numbers have to have the same sign because I'm multiplying to a positive 8. So let's make that a -1 and a -8, and sure enough, that works. So x minus 1 and x minus 8 equals 0. The only way for me to multiply two factors together and get an answer of 0 is if at least one of those factors is 0. So I'm going to take both of my factors and set them equal to 0. So x minus 1 equals 0 and x minus 8 equals 0. Solve both of these equations like you would any equation, and then that should be it. So we have x equals 1, x equals 8. On part B, do we see or actually, is everything on one side equal to 0? Yes. Do we see a GCF other than 1? No. How many terms do we have? 2. It's subtraction, and both of the terms are perfect squares. So that means this is the difference of two perfect squares. Square root the first term, so square root of x squared is x. That goes in the first slot of your two sets of parentheses. Square root the second term, so square root of 9 is 3. That goes in the back slot of your two sets of parentheses. Make one positive, make one negative. Now that you've factored, set each factor equal to 0 and solve for x. So it looks like we're getting x equals -3 and x equals +3. And then that last one, part C, everything's on one side equal to 0. So we want to try to factor. Is there a GCF other than 1? No. Is it, let's see, it's a trinomial. It has 3 terms. And the first term has a 3 in the front, not an invisible 1. So this is going to be advanced factoring. So we want two numbers that multiply to a times c. So a times c would be 3 times 4, which is 12. Those same two numbers need to add up to the b value, which is -8. So I'm thinking -2 times -6 is +12, and -2 plus -6 is -8. So we're going to drag down the 3x squared in the front. We're going to split the -8x into -2x plus -6x. And then we'll drag down the +4, and we'll drag down the equals 0. So now we're doing factor by grouping. We group the first two terms together. We group the second two terms together. So looking at that first set of parentheses, I see an x as my greatest common factor. So divide the x out in front. Leftovers would be 3x minus 2. Looking at my second set of parentheses, both of those are divisible by a 2, and I want to make it a -2 because that 6 is negative, the -6x. So I want to take out a -2. That way all the signs are going to match instead of all being opposites. Then, I did it again. -6 divided by -2 is 3x. I was missing a 3 in the parentheses. Sorry about that. Now that those pink 3x minus 2's match, I'm going to divide the 3x minus 2 out in the front as a greatest common factor. And then the green leftovers are x minus 2. Now that everything's completely factored, you're going to set each factor equal to 0 and solve for x. So on that equation on the left, just add 2 to both sides and then divide by 3 to undo multiplication. So x equals 2/3 for one answer, and then just add 2 on both sides for the other equation, x equals 2 for the other answer. For number 3, algebraically determine the x-intercepts. So if you're on the x-axis of a graph, you haven't gone up, you haven't gone down, so your y-coordinate has to be 0. So you're going to let y equal 0, and then you're just going to solve for x, just like we did in the 3 previous problems on number 2. So when looking at part A, I don't see a GCF. I see 3 terms, and the number in front of the x squared is an invisible 1. So this is a basic trinomial. So you want to find 2 numbers that multiply to 1 and then add to -2. So -1 times -1 is 1. -1 plus -1 is -2. So this is x minus 1 and x minus 1. Set each factor equal to 0, solve for x. So you basically get the same answer twice. You could just write it once, x equals 1. I'll go ahead and just show you both. So x equals 1. Looking at, it says x-intercepts. So let me back that up real quick. Let me not circle x equals 1. So let me not circle that. This is why I'm always constantly double checking things. So if it asks us specifically for x-intercepts, we want to write our final answer as an ordered pair x comma y. So do 1 comma 0 instead of just stopping and leaving it x equals 1 like I almost did. Looking at part B, f of x is the same as y. So I'm going to put a 0 in instead of f of x. And then I'm going to factor, set each factor equal to 0, and solve. I see no GCF other than 1, and I see a 3 in front of the x squared. So this is advanced factoring as opposed to a basic trinomial. So I want to find 2 numbers that multiply to a times c, and then they need to add up to b. So a times c is 3 times -8, which is -24, and then b is 10. So 12 and 2, but then I need one of my numbers to be positive and one to be negative in order to multiply to a -24. And then I want my bigger number positive because I'm trying to add up to a positive number. So sure enough, 12 times -2 is -24, and 12 plus -2 is 10. So I'm going to drag down my 0 equals 3x squared. I'm going to split my middle 10x term into 12x plus -2x. And then I'm going to drag down my -8 in the back. Then this turns into factor by grouping that we've been seeing a lot of recently. First set of parentheses, I see a GCF of 3x. So I'm going to factor out a 3x in the front. Leftovers are x plus 4. Second set of parentheses, since that -2x is negative, I want to take out a -2 as my GCF as opposed to a +2. And then leftovers are x plus 4. So the x plus 4's match, so we're going to divide the x plus 4 out in front as our GCF. Probably should drag down that 0 equals in the front. And then my leftovers in the green are the 3x minus 2. Set each factor equal to 0, solve for x, and then don't forget to write our answers as ordered pairs, like I almost did in part A. So it looks like I'm getting x equals -4 as one answer. I'll still have to write it in the correct form in just a second. and 3x equals 2. Let me slide this up here. 3x equals 2. We want to divide by 3 on both sides to get the x all by itself. And then as far as the final answers go, -4 comma 0 in parentheses, and then 2/3 comma 0 in parentheses. So we want those answers as ordered pairs when they specifically ask us for x-intercepts. For number 4, given f of x equals x squared, describe the transformations performed on the graph f of x to get g of x equals -1/2 x plus 3 squared minus 8. Negatives in the front like that are reflections over the x-axis. The a value in front has to do with vertical compressions and stretches. So since 1/2 is in between 0 and 1, that's going to be a vertical compression. If it had been greater than 1, it would be a vertical stretch. The +3 in the parentheses is a horizontal translation. They're always the opposite of what we think they should be. So since I see a +3, that actually means go left 3. So horizontal translation left 3. And then that last one in the back is a -8. So it's going to be a vertical translation down 8. So the vertical translations are as they should be. Down is negative, up is positive. 5. Match each parabola with its correct equation. Then determine the domain, range, interval of increase, and interval of decrease. So right off the bat, the concavity is different, so that makes it really easy to identify which one's which. So when I look at equation A, there's an invisible 1 as my A value, so I know that it has to be concave up. So this must be equation A, and then this must be equation B, because on B, your A value is negative, so it has to be concave down. Domain for both graphs is -infinity to infinity, because those are all the x values that are covered. Both of those graphs keep getting wider and wider and wider as they go up or down. Range is all the y values from little to big. So the graph on the left, you have -infinity, and then you keep going up all the way to whatever this is. So that looks like a y value of 1. So -infinity comma 1 with a square bracket around the 1 because you want to include that in your answer. Range for the second graph, my lowest y value is right down here at the bottom. So that's -16. And then I keep going up forever and ever and ever. So -16 comma infinity. For interval of increase and decrease, it's usually very helpful to jot down some infinity signs on your graph. And it also is usually very helpful to jot down the x coordinate of your vertex, because that's where your graph changes if it's going up or if it's going down. So with the graph on the left, I'm going to put a -infinity on the left and a positive infinity on the right. And then the x-coordinate of the vertex, or the axis of symmetry, is -4. So those are the only values that are going to be in my interval of increase and decrease. It's going to be -infinity, -4, and infinity. There will be no other numbers involved. So as I'm looking at this parabola from left to right, I am increasing. I'm going up from -infinity to -4. So I'm increasing from when x is -infinity to when x is -4. Then as I keep looking, I'm decreasing. I'm going down from when x is -4 to when x is positive infinity. For the other graph, let's put my -infinity on the left, my positive infinity on the right, and then let me get my axis of symmetry in here to split the graph in half. And that x value looks like it's a -2. So as I'm looking at the graph from left to right, I'm decreasing. I'm going down from -infinity to -2. and I'm increasing, going up from when x is -2 to when x is infinity. Number 6 is kind of squeezed off here on the right side. It's another transformation question. So the 4 in the front, since it's bigger than 1, that's a vertical stretch. The negative sign, it's inside the parentheses directly in front of the x. So that's a reflection over the y-axis. And then the +5 in the back is a vertical translation up 5. Number 7, find the vertex, x-intercepts, and y-intercept of the following function. Either show work or explain how you got each answer. So we're in standard form. So when you're in standard form, you want to do x equals -b over 2a in order to find the x-coordinate of the vertex. And a and b and c just go in order like I have labeled. So b is 6, so -6 over a is 3. So -6 over 6 reduces down to -1. So that's the x-coordinate of the vertex. In order to get the y-coordinate of the vertex, I want to take my x value, my -1, and I'm going to plug it into the equation in parentheses wherever I see an x, like so. When simplifying this, make sure you follow order of operations. So you have to do exponents before multiplication. So -1 squared is +1. And then 6 times -1 is -6. And then drag down your -9. 3 times 1 is 3. And then 3 minus 6 is -3. And -3 minus 9 is -12. At the end, make sure you write your vertex as an ordered pair, x, comma, y in parentheses. For part B with x-intercepts, if you're on the x-axis, y has to be 0. So we have 0 equals 3x squared plus 6x minus 9. I see a greatest common factor, so I want to factor out the 3 first. So if you see a GCF, you always want to factor that out first. Then, looking at my leftovers in the parentheses, it's a basic trinomial because the number in front of the x squared is the invisible 1. So you're looking for two numbers that multiply to -3, and then they have to add to +2. So 3 and -1 multiply to -3, and 3 plus -1 is +2. So x plus 3, x minus 1. Next, set each factor equal to 0 and then solve for x. So that first equation, 3 equals 0, that doesn't make any sense, so we cross that off. The other way we could have gotten rid of that 3 was dividing by both equations by 3, by dividing both sides of the equation by 3. That would have been another way to make that 3 kind of disappear. As far as the other two equations go, just solve like normal. And then it looks like we're getting -3 and 1. And then remember, be careful, we want our final answer to be written as x-intercepts. So -3, 0, and then 1, 0 for our two x-intercepts. And then that last one, part C, if you're in standard form, the y-intercept is always the c value, so 0, -9. And the reason that happens is if you're on the y-axis, you haven't moved left or right, so x has to be 0. So really this is what's happening behind the scenes. 0's getting plugged in everywhere, and then everything cancels out except for the c value in the back. Number 8. Describe at least 2 key characteristics of each function. Explain your reasoning in complete sentences that use proper mathematical vocabulary. So on all of these problems, you definitely want to mention the form you're in order to get the point across about which key features you can find easily. So, for example, on this first one, since we're in standard form, the y-intercept is 0, c, which is 0, negative 31. And then it's concave down because of our negative a value, because a equals negative 10. For part B, we're in factored form. So since we're, that's not how we spell that. Since we're in factored form, the x-intercepts are negative 6, 0 and 9, 0. Because your x-intercepts are your r values, and the r values are the opposites of the numbers in the parentheses. And then concavity, of course, is the other thing that's always easy to find. So it's concave up because a is 2/3. So anything positive makes it concave up. And then that last one is in vertex form. So we'll be able to get the vertex, the concavity, and the axis of symmetry. So since we're in vertex form, the vertex is, and the vertex is always the opposite of the number inside the parentheses, and then it matches the number in the back. So negative 7, 11, because the vertex is h, k. So negative 7, 11. And if we know the vertex, we know the axis of symmetry. So, and the axis of symmetry is x equals negative 7. And then last but not least, concavity. So it's concave down because a equals negative 4.